Section 9.7 parametric differentiation. So in order to find the derivative of a function defined parametrically, you will have to simply differentiate the y function and differentiate the x function and divide one by the other to obtain dy dx. This is, if you look at rewriting this division in that form, so to divide by dx dt means to multiply it by dt dx. You can see this is just the chain rule. Dy dx is equal to dy dt multiplied by dt dx. Or think about it as y differentiated, x differentiated, divide the y differentiated by the x differentiated. Okay, so example 19, it asks you to find the value of dy dx at the time when t is equal to 2. So dy dx is equal to dy dt divided by dx dt. So we need to find dy dt. This is going to be 2t. And we have to find dx dt, and this is going to be 3t squared plus 1. And then substituting these in, you will get 2t over 3t squared plus 1, making t equals to 2. You'll have 2 times 2, which is 4 over 3 times 2 squared plus 1. So it's 4 over 12 plus 1, 13. So this is the value of the gradient function at the time when t is equal to 2. Okay, example 20, we have to find the equation of the normal to the curve defined by two parametric equations, x equals 3 sine theta, y equals to 5 cos theta, at the time where theta is equal to pi over 6. So for the equation of the normal, I need to have two pieces of information. I need to have the gradient of the normal, and I need to have a coordinate of a point. So let's find the coordinate of the point. So let's have a point first. So when theta is equal to pi over 6, x is going to be 3 sine pi over 6. So that's going to be 3 times a half, so 3 over 2. Y is going to be 5 cos pi over 6, so this is going to be 5 root 3 over 2. So now we need to find the gradient of the normal. So first of all, find the gradient of the tangent. So dy dx, so it's going to be dy d theta this time, divided by dx d theta. So let's differentiate y. That's going to give me minus 5 sine theta. Let's differentiate x, that gives me 3 cos theta. So effectively, I'm going to do y dash divided by x dash. So y dash is minus 5 sine theta, x dash is 3 cos theta. Substitute theta equals to pi over 6. I will get minus 5 sine pi over 6 over 3 cos pi over 6. This will give me dy dx is minus 5 times a half over 3 times root 3 over 2. So it's minus 5 over 3 root 3. So the gradient of the tangent is this, so gradient of the normal, negative reciprocal, so it's minus 1 over this, which gives me that flipped, so it's 3 root 3 over 5. So using y minus y1, so y minus 5 root 3 over 2 is equal to the gradient, x minus 3 over 2. Now this is already the correct answer. We could tidy it up further to make it look a bit prettier, I guess. So we could expand it to get 9 root 3 over 10. So y is equal to 3 root 3 over 5x. And then if you add times that by 5 and that by 5, it's going to be 25 minus 9. So it's going to be plus 16 root 3 over 10, which is 8 root 3 over 5. So that is example 20, and that leads us to exercise 9G. We just had a quick look. The book actually, they decided to multiply everything by 5 to give the answer as 5y equals, this will be 3 root 3x, and this cancels to 5, so we'll be left with 8 root 3. However, if they don't tell you which form to give the answer in, when you get to this stage, you don't need to do anything else. So exercise 9G to follow.